These are your 12-2B notes, radian angle measures. So we are actually going to learn how to measure angles in a different format other than degrees. So that's called a radian. So I like to compare degrees and radians to like the U.S. customary inches, feet, miles, to metric. You know, the centimeters, centimeters, kilometers, that sort of thing. So it's just another way of looking at measuring the opening of an angle. So the unit circle, before we begin, we're going to be talking about the unit circle. The reason it's called a unit circle is it has a radius of one whole unit. So this circle down below here has a radius of 1. So if this radius here is 1 unit, okay, it could be 1 inch, it could be 1 foot, it could be 1 mile, okay, then this is also 1 because all radii are congruent. So if you take that standard angle in standard position, you've got your initial side and your terminal side, and they're both touching the circle, then what I want you to envision is taking like a string and measuring that radius and then curving it along the angle. And so this right here is also, this red arrow is 1 unit long. Since our radius is 1 unit long, you're taking that string and you're curving it along that circle, and that is also 1 unit. The angle formed by making a 1 unit wide by 1 unit wide angle is 1 radian measure. So that angle formed when you take the radius of 1 and move it along the side, that is 1 radian measurement. And so I'm just showing you the coordinates. You got the coordinate system there. Since it's 1 unit, it all goes around 1, 0, 0, 1, negative 1, 0, 0, negative 1. And just a couple things. All circles have 360 degrees, and the circumference of a circle is 2 pi r. So when you say a circle has 360 degrees, that means I could make 360 slices of pizza out of that circle. And each slice would then represent that little tiny slice. Think of a pizza cut in 360 different pieces. That little increment would be a degree, each slice of that 360 degree sliced pizza. When we talk about measuring the circumference of a circle, we're talking about the distance around the outside. So degrees are inside measurements, and circumference is on the outside. 1 radian is the measure of that angle that intercepts a circle in 1 unit of an arc. So we talked about taking the radius, moving it along that circle, and you get that 1 unit. Now in a unit circle, the circumference is 2 pi r, but your radius is 1 unit. So in the unit circle, we have 2 pi times 1, which is 2 pi. That's our circumference. And so the circumference is 2 pi r, and our radius is 1, so just 2 pi. And 2 pi radians is equivalent to 360 degrees. The 2 pi radians is all the way around the circle, and 360 degrees is also all the way around the circle. I'm going to show some work here, and it just bases the formulas below. It tells us how we get those formulas below. And it tells you how big 1 radian measurement is in terms of degrees, and it tells you how big 1 degree is in terms of radians. So if I wanted to figure out how big 1 radian is, I would try to get this one side of this equation to turn into 1. So I'm going to divide by 2 pi. If I divide that side of this equation by 2 pi, I also have to divide this side of the equation by 2 pi. And that leaves me with 1 radian is equal to 360 degrees divided by 2 pi. Well, I can actually clean this up, and 360 divided by 2 ends up giving me 180 over pi. And that's how many degrees this is equivalent to. And when you actually divide that out, when you divide 180 by pi, you end up with a 57.3-ish degrees. So 1 radian measure is equivalent to 57.3 degrees. And so when you look at that opening from the previous page, that's how big this opening right here is. And if you look at our unit circle, this is 90 degrees. 45 would be right in the middle, so it's just above that 45, almost 60 degrees. That's what one whole radian is equivalent to. If you look at the other side here, if I want to know how many radians are in 1 degree, I would divide by 360, divide by 360 to get this right-hand side to equal 1 degree. So 1 degree is equivalent to 2 pi over 360 radians. The 2 and the 360 I can reduce to 180 again, but this time it's pi over 180. And when I actually calculate what pi divided by 180 is, it's approximately 0.017. So 0.017 radians are equivalent to 1 degree, which was going to be really small. So if I was looking at how many radians fit into a degree, this one makes a little bit more sense. That's how big 1 radian measure is equal to. You know, we talk in terms of customary and metric systems. I think it's like 3.5 centimeters equals an inch, roundabout. We kind of memorized that. So all of that work you'll never have to show, but it kind of shows where these formulas come up when we have to convert. So when we convert from one form to the other, we're either going to multiply by 180 degrees divided by pi radians, or we're going to multiply pi radians divided by 180 degrees. It just basically shows you a flip-flop of each other. And now you can tell where the 180 over pi or the pi over 180 comes from. So all you really need to know here is that we're going to multiply by this, or we're going to multiply by this, just depending on which way we want to convert. So that's what this whole lesson is converting degrees to radians and then radians back to degrees. So for these first 3 examples, I have the degrees, and I want to bring in radians. So to make the degrees cancel, I'm going to put this over 1 because we're multiplying fractions. I need to have my degrees in the denominator so that those degree symbols will cancel. And I need to have the pi radians on top. So this is your pi radians right here. So the 60 and the 180, the degrees cancel, and the 60 and the 180 turn into 1/3. So I get pi over 3 radians. So we're going to keep the pi symbol. We're not actually going to give the decimal. Pi is exact. 3.14 is an approximate, and even the pi key of the 3.14 on and on and on is just an estimate. So by leaving it as symbol pi, we are the most accurate. So we're going to say pi over 3 radians. And that's it. So if you want to do the calculations on your calculator, you can put this, instead of saying 60 divided by 180, put it in your calculator as 60 over 180 as a fraction, and it will reduce it to 1/3. And then you just got to remember to bring in the pi. So you kind of bring in pi as like an x. Think of it as a variable. The negative 160 degrees, put it over 1, and we're going to times it by pi over 180 again. Remember, we want the degrees to cancel. And so when you put that in as a fraction, it's still going to be negative. Okay? It doesn't matter if it was a negative degrees, it's going to be negative radians. And then 160 over 180 will actually simplify to 8/9. So we have 8/9 pi. The pi just goes on top with the 8. 415 degrees over 1 times pi over 180 degrees. Okay, we're going to put that as a fraction instead of a division problem, and it'll reduce it for you. 83/36 pi. Which makes sense because 1 whole pi would be 360 degrees around. That would be 36/36. This went around 1 time and then some. And there's where the 83, that's why it's improper. Change the radian measure to degree measures. Same thing, we're just going in the opposite direction. And so we've got to get the radians to cancel. So pi is the radians, we got to bring in the degrees. So 180 divided by pi, those are going to cancel. Again, type the other information as a fraction. 180 over 12 gives me 15 degrees. 9/5 pi times 180 degrees over pi. The pi's cancel. So now I'm going to do 9 times 180 over 5, write it as a fraction. So you want to do the 9 times 180 first. That will be your numerator. And then you want to put that number, which I got 1620, over 5. And so that's 324 degrees. And negative 3/2 pi times 180 degrees over pi. The pi's cancel. Negative 3 times 180 is negative 540. And when you put negative 540 over 2, you end up with a negative 270 degrees. So that's the first part. The second part is we're going to do coterminal again, but we did coterminal where we added or subtracted 360. One thing you have to keep in mind is that 360 degrees is one time around inside the circle, and 2 pi is one time around the circumference on the outside of the circle. So those two numbers you have to memorize are the same thing. One time around is 360 degrees, one time around is 2 pi. Now these get a little tricky because we're going to add and subtract 360 degrees to find coterminal. But we're not going to add 360 degrees, we're going to add or subtract 2 pi. I show my work. So if you want to add 2 and subtract 2 and just throw the pi in there, that's fine. So you're going to have 7/3 pi plus 2 pi. That's going to give you a positive coterminal. And then 7/3 pi, take away 2 pi. I think we actually have to do it twice. So if you use your calculator and just treat it like a fraction, 7/3 plus 2 is going to give you 13/3 pi. If you take 7/3 and subtract 2, I get still a positive 1/3. So I have to subtract 2 again to get my negative 5/3 pi. Now, how did I know that we'd have to do it twice? 7/3 is more than 2 pi. 2 pi in terms of thirds is 6/3 pi. Okay, so you got to double the top. That's 2 pi. That's just, it's 2 pi in terms of thirds. Negative pi over 2. Okay, same thing. We're going to add 2 pi to it, and we're going to take negative pi over 2, and we're going to subtract 2 pi from it. So just use your calculator and treat it like a fraction. So that's a negative 1/2 plus 2 gives me 3/2 pi. Just don't forget to put the pi in there. And then negative 1/2. And then we're going to subtract 2 from the negative 1/2. And you get negative 5/2 pi. And the last one is 6 pi. 6 pi is actually going around the circle 3 different times. Here's 2 pi radians, 4 pi radians, 6 pi radians. So we're already pretty big. So I'm actually going to subtract 2 pi to get a positive, which would be 4 pi. I got to take that 4 pi and subtract 2 pi again, which takes me to 2 pi. And if you want to just take the 2 pi and subtract to get to the, do a little thinking and say, how do I get to the negatives? I got to subtract negative 4 pi. So negative 2 pi is there's your negative. You've got a couple positives in there. Any one of those would work. Okay? So it's just adding and subtracting 2 pi. For number 10, we got both degree. We want to find both degree and radian measures. When the clock hand rotates, the hour hand rotates from 6 p.m. to 10 p.m. So we're going from 6 to 10. And so we're talking about this angle measure right here. We want to know that angle measure. What we have is a clock. A clock is 360 degrees all the way around, but it's divided by 12 equal hours. So if we divide the 360 degrees equally by 12, each hour represents 30 degrees. So it's a 30-degree angle in between 12 and 1, 30 degrees between 1 and 2, all the way around this clock. We actually, from 6 until 10, rotate through 4 hours. So 30 degrees times 4 is a total rotation of 120 degrees. So find the degree measurement is 120. Now to find the radian measure, I just simply take the 120 degrees. I want to get rid of the degrees, so I put that on the bottom so that the degrees cancel and bring in radians. So 120 divided by 180 is 2/3 pi. And there you have it. So your lesson summary is to tell me how many degrees is 1 whole radian, and I want you to find the radian measure equivalent to -200 degrees. Good luck.